You can see.
I go try.
Speaking, my mic would be here with the laptop. Mic's right there. So why did I unmute my
Only
mic?
the, yeah, please,
Yeah.
because the recording.
So should I mute my audio?
So it has to be.
Oh, it was muted before. Okay.
Yeah.
Oh, wait,
Yeah.
All right, let's bring it back. Bring it back to the front. So, if you think the left diagram best represents the memory. Okay. Now, if you think the right diagram best represents the memory. So like none. But you guys are all correct. Here it is the left diagram, right? In OCaml, all of these values are heap allocated. So when we make the strings here, on the heap. When we make this array here, on the heap. You might think, like if you come from C, that if you make this array here, it'll be stack allocated. But no, heap allocated. But we want to change that. We don't want this heap allocation, right? So this function is named really, really well, because what bad thing could happen given all of these heap allocations in this function? Just shout it out. You don't even have to raise your hand.
if the array is returned. If the array is returned, then.
If the array is returned, okay, but if I just have these allocations and my function is performance critical, what might happen?
Yeah.
GC, we have a garbage collector, right? Someone's got to look at these things. There could be a garbage collection cycle. And relatively speaking, that is a slow thing. And so if we have this performance critical function, maybe we're like trading a bunch of money, then we don't want the garbage collector to interrupt us. But if we want to avoid these allocations, going back to the answer in the back, what would the compiler need to know and do to avoid them? You can also shout it out. An escape analysis. Why an escape analysis?
If we don't return the array, there's no set.
Right? If we don't return the array, the code's up. If we don't return the array, then we know that we can safely locally allocate the array, and then we avoid that allocation. So we can perform an escape analysis, and then the second thing we need to do, this one's obvious that it's hard, is you actually have to update the code, right? You can run an escape analysis. You can say, symbols doesn't escape the function, but if you don't actually go and update the code to make that a local allocation instead of a heap allocation, then you could still have some allocations there. Now, OxCaml provides both of these facilities for us, so we're going to walk through how these work. In this code, we want to assert that symbols does not escape the function. And how we do that is we use this @local syntax. Right? So this is telling the compiler, hey, we expect that this thing does not escape the function. And then the compiler will check that for us. So if we did try and return symbols, it would say, hey, you said this thing doesn't escape, but it's escaping. That's bad. And it turns out every value in OxCaml is either local or it's global. Global are all of the values that you have in OCaml. That is sort of the default thing. Right? These values can live forever. They're global. But if we say something is local, then we're telling the compiler that that value doesn't escape the current region. And if people have questions, just like raise your hand and stop. This is totally interactive as well. And then the key thing is that a value that is local could be locally allocated, right? This is the escape analysis portion of OxCaml. Now, this is not actually updating the allocations, it's just doing the escape analysis. So now let's go in and add the actual local allocation. So we want to ensure that symbols is locally allocated. And we do that with one of two keywords, stack underscore or exclave underscore, and we'll explain both of these. So stack underscore, we can put right here. I can write on the slide, so I'm going to use it as much as I can. We're going to put it right there. And what this is telling the compiler is, hey, we are going to locally allocate this expression. And I have this at local here, because this is telling the compiler, hey, symbols doesn't escape the current region. But I can actually add stack here and leave out the at local, and the compiler knows that symbols is at this local mode. All right. So there's one little technical bit that I'll have to explain, and this is something called the local region. But I've been careful to say locally allocated instead of stack allocated for one specific reason. So when we have our perf critical function here with the stack keyword, that looks something more like this Rust code on the right. I don't expect you to know Rust. You don't need to know Rust. Rust just makes explicit what the OCaml code is making implicit. So implicitly in this OCaml code, we have a local arena allocator attached to every function. And when we say stack underscore array, what this means is we're going to locally allocate that array in our arena. It's right here. And so when the function ends, everything in the local arena also gets cleaned up. There's no garbage collector involved, but it is still a dynamically sized arena allocator there. All right. So I've given you some partial information, and I'm interested to know, with the information you have currently, which of these diagrams best represents the state of memory now in this perf critical function using the stack keyword. Talk to your neighbors, and then we'll vote in a second.
Yeah, because it's specified on
I'll tell
I guess we're comparing the arena.
There's another.
All right, let's come back. I hope everybody has an answer in mind. So let's go ahead and vote. Who thinks, by way of humming, the top diagram represents the state of memory after binding symbols? Okay. Who thinks the bottom diagram represents the state of memory after binding symbols? Oh, like 3 people? Okay. Why somebody over here hummed? Why might this be the diagram? I said might. I'm giving you the answer. Yeah. Why might this be the diagram for the code?
Well, I thought that the array is local, then we put the variables inside.
Yeah, the array's local. Why not allocate the stack and the strings locally, huh? That'd be great. So it turns out the answer is the top one, because stack only controls the allocation for the array expression. Gensim, which is a separate function, still allocates the strings on the heap. And we can actually analyze this just from the type signature. So this is the type signature of Gensim. It goes from unit to string. And I'll remind you that every value in OxCaml is either at local or at global. And implicitly, because the default for OCaml is at global, what this means is the return string is at global. So Gensim is going to allocate its string on the heap and return that, and that's totally fine. Local allocation will require cooperation from all of the callees. So if we want Gensim to allocate locally, we have to change the implementation a little bit. And here's how we might do it. So we're now going to abstract our array creation into a separate function called gensim2. Just does the same thing, right? Creates the array, gensims, and returns that. Now, if we run this code, well, it doesn't run. There's a compiler error, and it says that the expression is not an allocation site. Because just calling gensim to the function, that expression itself is not doing any allocation. It's the code inside of gensim2 that is doing the allocation. So we might be able to move stack, up into the implementation of gensim2, but we get another compiler error. And what this says is the value escapes its region. So this goes back to what I said earlier. When we write stack underscore, that makes that value local to the current function. And we don't want the array allocated locally to gensim2 because we do need to return it. We want it allocated locally to the perf critical function. And that's exactly, some Rust code before we get into that. The equivalent of this code is, allocating something in the local arena and then returning that pointer, which is unsafe. Because as soon as we leave that function, once we hit that curly brace, our local arena is going to get cleaned up and all the memory in it, and we would be returning a pointer to that memory. So that is a dangling pointer there. So how we actually do it is we use the exclave keyword. And what that means is it's going to allocate the value in the caller's local region. So this is sort of what the memory might look like here. And when we allocate this array, we do it in the caller's local region, right? So there's that horizontal bar dividing the two local regions. And when we return from gensim2, its local region gets cleaned up. And then we have the array properly allocated in the local region for perf critical. Nice. Now, this code is sort of a similar variant of everything we've seen so far, right? I'm going to locally allocate a tuple of strings, and then I'm going to return the first element of that tuple. And of course, this would be incorrect code because that string could be locally allocated. And so we'd be returning a dangling pointer here. I forgot to mention these confused OxCamls in the corner mean that the code doesn't compile. So if you ever see that, it means the code's not compiled. Now, if we rewrite this function to use genInt, gensim's sort of estranged cousin, it's just a counter, right? And we return the first element of the tuple, even though it is locally allocated, this code does compile. Wow, you're shaking your head like you're really agreeing.
It's immediate. It's an immediate the return register.
Yeah, right. Integers are not allocated values. They're just on the stack. So instead of returning a pointer, we're actually just returning the integer. So it's safe to return a locally allocated integer or,
Yeah,
because there's no allocation. Locally allocated integers and globally allocated integers sort of mean the same thing. They're just integers. That's what I just said. All right. Now, when we're writing our code, we might want to ensure that a function is zero allocation, right? If we have a really performance critical function. And OxCaml comes with a set of extensions. One of them is this @0alloc attribute. And so we can put this on our functions. And then the compiler will tell us, hey, this code here, this array.init, calls camel makeEffect, which is the function to globally allocate the array. And 0alloc uses some abstract interpreter to check if the extent of your functions is 0alloc. So it will check function and the functions you call. Right? A lot of the functions that are provided from the standard library or base come with versions that locally allocate things. So in the current version of OxCaml, you would write @alloc stack after array.init, and that's specifying that we want the version of array.init that locally allocates the array. Now, this is something that is most likely going to change in the language, so don't get too attached to the syntax or too dissuaded by the syntax, but that is how you currently would specify it. But it turns out this code also doesn't compile, right? Because we never changed gensim. Gensim still allocates those strings on the heap, and we'll leave that as an exercise for later. All right. So far in our whirlwind tour of OxCaml, we've seen new keywords like stack and exclave, which give you control over the memory allocation. We've also seen these annotations @local and @global. And these things can appear on let bindings, but they can also appear in type signatures that specify the local or globalness of the values being returned there. And local and global are instances of what OxCaml calls modes, which is the major change to the type system over OCaml. And modes are how OxCaml provide safety. So let's talk about modes for a little. In OCaml, we have a whole bunch of values. So we have things like these over here, which we call broadly strings. And then we have integers, and we have floats, and we have arrays and lists of things. And types give us a way to ascribe properties to a value, right? So if we have a string, we know that that value is immutable because strings are immutable enough. If we have, an integer, we know that that is not allocated and it's just an immediate value, etc. Right? Strings give us properties of these values. Modes also ascribe properties to values, but they ascribe properties that make sense for a whole bunch of different types. So for strings and floats and arrays, I can say that these things are local. And I could have drawn this bubble around any subset of these values, and it still would make sense. So our broad definition of what is a mode is that modes are deep properties of values. You can read that for a second. Now, when we say deep, what we mean is if you have, an array of floating point numbers, not only is the array assumed to be local, but also the elements of the array, right? Types are not deep. I can have an array of floats, and both of those types describe the different elements, but here modes are deep. So if you have an array of something, the array and the elements are assumed to be at that mode. Now, example properties of what modes might give you is things like a value doesn't escape the region, the local mode. We can say that a value is unique, so there only exists one pointer to this value. A function may be called from any domain. If you're not familiar with OCaml, that's synonymous with thread here. A function can be invoked at most once, and lots of other properties. And modes provide the safety to OCaml. So we're going to talk about data race freedom in a second, and we just talked about memory safety. Now, a bit more formally, the locality axis is what we've just been talking about with stack allocation here. So the locality axis has two modes. There's the local mode and there's the global mode. And there's actually a sub-moding relationship between these. So here we would say that global is a sub-mode of local. And that is how this code was able to type check earlier, right? We have the local symbols, but we don't have the stack here. And we don't have the exclave here. Right? So nothing is actually doing this local allocation, but we can say, symbols is local, it doesn't escape the region. It's just an escape analysis. And then every mode has a default for OCaml values. For the locality axis, that default is global. And in these tables, I will highlight or bolden the defaults. And we call the @local a mode annotation. Questions up to here? Yeah. Good. So mode crossing is this thing that we saw earlier where we said integers at the local mode and integers at the global mode don't make a difference, right? Because integers aren't allocated here. And so this works, like this code here works, because integers cross locality. And what that means is an integer is the same at local and global. And there are values that cross along a lot of the other mode axes. And we'll see some examples a little bit later. All right. And the high level takeaway from here is that mode crossing happens when the type, the properties of the type, actually work with the properties of the mode. So we know because integers aren't allocated, they can mode cross freely along the locality axis. That's our sort of theory. That's it. All right. Now we're going to get into some parallelism. Actually, let's take a 5-minute break really quick. Talk to your neighbors, 5-minute break, then we'll talk about parallelism. Go. Are you in
That's like extreme violence. It's like violence. I got it to yoga. For my back.
Takes a while.
But if you want like text okay.
It's like 15 or 16.
All right, let's come back. We're coming back. All right, so OCaml 5 is incredible. There's a lot of people here that worked on it, and it introduced true parallel programming with a multi-core aware runtime effects. But it woo! But it also unleashed chaos, right? My life is now hell because I have these race conditions and data races and non-deterministic bugs and all this hard to reason about code. So it's good, but it's also bad. And we want to tame all of these bad things here. And we want data race free. I don't want to be sure that my code has no data races. So OxCaml introduces two mode axes that work together. And these are called contention and portability. So we're going to modify our gensim example again. And now we have this gensim n function that is going to generate an array of length n. And then you're going to have all of your gensims. Now, this uses the parallel array module. So when it calls init, it's actually going to evaluate all of those functions in parallel for each of the elements of the. All right, now I want you to talk to your neighbor and come up with some bad thing that could happen if I call gensim n with an n that's greater than or equal to 2. Discuss.
Oh, yeah.
You're in good company. Actually, don't that is not as common.
Let's come back. A lot of good discussion. Who wants to tell me what they talked about? What bad thing is going to happen here or could happen?
Data race.
Data race. Okay, what could happen if there's a data race?
Identical symbol.
Identical symbols, right? Gensim is supposed to give me a unique symbol, but now, right? Here's a little example. We have one domain running on the left. It might read the count variable at 0. Our other domain is running on the right. It also reads count at 0. Okay, now on the left again, we're going to increment it from 0 to 1. On the right, same thing. And now when we read it at the end, count is 1 on both domains. And that means that our array has 2 gsim 1s. And that is bad. So my code was not expecting that, and it breaks. And I don't know why it broke, and now I have to debug it. My life is hell. So it is unsafe to run gensim on multiple domains. And we want to statically prevent this from happening. So we might reason about this by saying that. Sure. Okay. Backing up a little. A data race requires 4 ingredients, right? There needs to be parallel execution. We have to actually have things running on 2 domains. There needs to be some shared memory. That's a location accessible by the domains. There needs to be at least 1 write. And there needs to be no synchronization on the memory. So if we pull back up the gensim function, we can identify all 4 of these ingredients, right? So this ref0, this is our shared memory. Bare references do not provide synchronization. Then we have, let's see, right here, we have our write and our read from count. And then we have another read here. And then, of course, if n is greater than 1, we have some parallel execution. So we might reason about this by saying, well, this lambda, right? This lambda it must be safe to share across domains. And so therefore Jensen needs to be safe to share across domains because that lambda calls Jensen. We say, well, Jensen closes over this non-synchronized mutable reference and reads and writes to it. So that's bad. So Jensen is not safe to share across domains. Therefore, neither is the lambda. Right? That's sort of like the high level reasoning we just went through. But when you have a really large code base and you have different modules, that's harder to do. So we introduced these mode axes for expressing parallel constraints. So the first is portability. And the question that portability asks is this value, but really we only care about functions here, is it safe to share across domains? Now, the portability axis has two modes, portable and non-portable. Portable means, yes, I can share it across domains. Non-portable means no, I cannot share it across domains. So if we have a value that is non-portable, the property that we assign to that value is that the value isn't shared across domains. Right? And so if we look back at our function and we annotate Jensen as saying it needs to be portable, the OxCaml compiler is going to say, well, it isn't portable, and I'll show you the error in a second. And it needs to be portable because the type signature for the par array init right here requires that that function f is portable. Right. All right. Now, the second mode axis is contention. And what contention asks is, what access do I have to this shared memory? And there are three modes in the contention axis. So one of the modes is uncontended, meaning I can freely read and write to it, right? It's uncontended. There's the shared mode, which means that I'm sharing it with a bunch of other domains. So I can read from it, but I cannot write to it. And then there's contended, which means it's shared with a whole bunch of other domains. And so I can't read or write to it. And the assumption is that if there's a contended reference somewhere, someone might have an uncontended reference to that value, right? So if there's one uncontended reference to a value, someone could be reading and writing to it, so nobody else can. So the property of a contended value is that the value isn't read or written. The property of a shared value is that the value isn't written. And then the property of the uncontended reference is we don't know, anybody can do whatever. So I'm just going to shuffle the rules a little bit. And there's one very important rule that ties the contention and portability axes together. And that is that references captured by portable functions are contended. So in this function, right, we expect that Jensen is portable, but it captures the count variable, right? Count reference here, and here, and here. And so inside of the function, count is inferred as contended. It is a contended reference because multiple domains might have access to it. But we're trying to read and write to it. So the compiler is going to say, well, this value is contended, right? It was closed over in a portable function, but it's expected to be uncontended because you're doing all this stuff to it. And so the compiler has cleverly caught our shenanigans, right? We're trying to read and write to something that is shared across multiple domains. So we may want to actually safely work with mutable state. And for this, we have atomics, and we also have capsules. Now I'll explain sort of what both of those things are. So atomics are exactly what you'd expect here. So we can make an atomic, and then we have this fetch and add, like a fetch and anchor operation on the atomic. And now this code actually type checks. So my question for you is, why is it safe to use atomic here, but it wasn't safe to use a rep? Why does an atomic provide that a reference does not? Synchronization. 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 You got it right the first time. So, yeah. Right. It provides synchronization. And so it's safe to share it across all of these domains. And so because atomics, the type atomic, provides synchronization, it actually crosses portability and contention. Right? So this is our second instance of mode crossing here. So even though inside of our function, count is contended, we can read and write to it, or specifically this fetch and add count can exist because it's shared. And it's because it synchronizes the memory. Sorry.
Question?
Question.
What about the string concat?
What about the string concat? What do you think?
Well, doesn't that raise on the allocation?
Does it race on the allocation? So if we have two domains running and they both run a concatenation, they're just separate allocations, right? So we have two separate string allocations. And because the runtime is, multi-core aware, the runtime will safely have the allocations.
So that will be a pass operation. On the allocation point of it, it will actually need to do something special in the.
There's different heaps for different domains.
Okay, separate domains, separate heaps.
Yeah, so the Camel 5 runtime takes care of that because the GC is due anywhere. So here the only race is the actual.
So that may come with a little overhead, right?
Is there overhead for that?
No, the pools are separate. So
Yeah.
each domain has its own separate key.
Different key.
Yeah.
So we have different heaps for those allocations. More questions?
I mean, I think this is super cool. This is not a quick. I feel like the synchronization is slightly sneaky, right? I mean, the fact that it's synchronized doesn't make the code correct. It's the fact that you choose to use the fetch and add and also synchronize it. But you could read and write like you did in the old code.
Yeah, so what Alex is doing, I'm just kidding. I have an example in 5 seconds that's going to hit us, right? We'll come back to that. That's a really good comment. Another question.
To his point though,
Yeah.
about the separate domains, that's why you don't need to call atomic again, right? For the next function, for the the concatenation, right?
Yes. The only shared memory was the count.
Right.
Right. And so that memory needs to be synchronized. Here.
Yeah.
And atomic provides that synchronization.
Right. So I'm just like adding some context.
Yes.
To this question.
Yes. That's correct. More questions? These are great questions. Ask away.
So is contended only useful for synchronized in practice? Is it only useful for like compiler error messages and for synchronized values? Because otherwise it's always you can either something that you can't use or that is a mistake to use.
Either can use or is a mistake to use. So this is a good question, and I'm going to answer it with one more change to Jensen, right? So now in our code, it's called make Jensen, and we can optionally provide our own prefix. So instead of just gsim, we could provide another prefix. Now, when we do the string concatenation, we're actually reading the prefix. And that was closed over by this lambda. Is that your question here? Because now, it's shared, but this code compiles.
It's shared.
It's okay. Well,
it's not contended.
Yeah, useful.
It's immutable.
Yeah.
So this is another example of mode crossing, right? The string type is immutable. And so contended exists because somebody could be writing to that memory. But the type string itself prevents the writes. So we know that it is fine to read that variable. And so, for example, if you have a record and one of the fields in the record is mutable, but the other fields in the record are immutable, you can actually read from immutable fields because they mode cross along contention. So even though they're contended, we can read from them. Does that answer your question?
Yeah.
Okay, cool. These are great questions. Any more?
So one more quick. This was for later to actually get the strings implemented in the stack, right? Because then you start having problems with.
So if we wanted to like locally allocate this prefix or something,
Yeah, or the result of the function.
So the result of the function, we could do, right? Because that is just whoever called this function is in some domain where they have a caller, and we can locally allocate the string and the column if we wanted to. We couldn't, for example, locally allocate this prefix because that would be for this function, but we're returning the lambda which captures it. So that would be escaping its region. Does that answer your question? Yeah, okay, we can talk about it again later. More questions from this side of the room. I feel like we're a little divided, but I promise. Yes.
Can you do anything with a contended value?
Can you do anything with a contended value? Contended mutable references? No. If it is an immutable reference, right? So like I said, if you have an immutable field of a struct, then you can read it because the immutableness of the type is preventing other people from writing. And so that makes it safe to read. That's good. More questions.
What happens if you don't put the at portable on some functions? Let's say you have a ref, you have the unsafe version, and you forgot to assert that it should be portable. Because in regular OCaml you can, and OxOCaml claims to be compatible.
Yep.
So how does this start?
How does it work? Right. So all of the examples throughout these slides have been in OxCaml.
I know.
And previously, we didn't expect Gensim to be portable because we weren't trying to send it across domains. The reason in these examples it needs to be portable is because we were using that parallel array.init.
So
and that function asserts that the lambda it runs to initialize all the elements in the array must be portable. That lambda calls Gensim. Gensim must be portable.
So you're basically you have to write your part array in an OxCaml way. You have to rewrite that part, and then every time you use it, it's automatically gonna check that you did everything.
It will check that all of those functions that it calls are portable.
But if you use the stdlib, the regular one, then unsafe things can still happen.
Then yes, then you're debugging for a really long time.
Yeah.
Yeah, that's true. But yeah, so if we didn't write portable here and we were still using ref, it's a non-portable function. So as long as we're just calling it on one domain and we're not trying to share it across domains, totally fine. You can do that. Your code. Question.
What if we are using atomic, but we did not write portable?
Then as long as it is portable, it will be so it will infer this at portable. We didn't have to write it. I'm just making it explicit here. So as long as your function is portable, then we're good to go. No compiler errors. Yeah.
Okay, so it's SPLASH' providing replacements for these types? Or like, is it the name the same thing as it would be in the standard library?
No, it remains the same thing. Yeah. So the thing that might change are some of the, the libraries exposed. So for example, if we want a function that returns a locally allocated value, that function needs to sort of be rewritten in an OxCaml way to allocate it locally. And if it, provides the type signatures, we'll have to write them. But they're like the basic module re-exports a lot of these functions with type signatures as well.
So is it the library author of RInit that has to say this has to be portable?
Yes.
What is so if the author of this library makes an error, then the users will also have data races.
Yes, if you have bad libraries, you also sort of inherit that badness a little bit and go back.
So the compiler doesn't know that.
No, Chris is disagreeing with me. Listen to Chris.
OxCaml is going to prevent you from writing a data race. But as long as you use, so one thing to say about Perk is that it has magic inside to be, and as long as you use the OxCaml provided libraries and don't use standard, then you will be unable to write a data race. There's no way to do it. There would be no way to give to write parent it and expose it as long as you're building OxCaml libraries in a way that provides parallelism if it wasn't enforcing the working.
Yeah. So the question is, if I write this par array in normal OCaml and it's just an OCaml library and I use it in OxCaml, has no annotation, then yeah, you have a data race, but you should be using the OxCaml provided version of that library, which then you would prevent your data race.
That's no different from Rust. If you're writing stuff in unsafe, Rust will bet it's wrong.
Yeah, I mean, I can just write C code and unsafe Rust. I got dangling pointers.
I can write C code and a camel too, it'll be local.
Yeah,
I'm more interested in a number of questions, which is if you've got a contended reference.
Okay.
Presumably you can either return that or do a physical quality check on it. So look at the reference itself, not at the reference, if you use point of 13.
And the other one was another fun pattern that Rust you can do is you will effectively have a function that allocates in the crawler's stack frame. How do you do that? Presume that you parameterize a function with the region into which the result is.
Yes, so that
So
is
there's a difference between local meaning local my frame and local meaning local sum frame.
yes. So that would be that exclave keyword that I mentioned earlier. So if I write exclave, it says, hey, allocate these things in your callers stack.
Well, does it presumably it means that presumably is that parameterized? That would be in Rust with what they call lifetime. I wouldn't say lifetime, then I need. So
yeah. In the current version of OxCaml, no, you use sort of a template PPX rewriting, so you can provide multiple versions. I've heard that.
Template PPX.
I've heard that this will change, and you'll have a nicer experience in the future. Currently, it's just with the template. So that's why we had to say like alloc stack when we called array init, because we wanted the version of array init that allocates.
So exclave is an exclave like Kaliningrad. That's depressing to say. I'm going to say Kaliningrad.
Not familiar with whatever you just signed.
Kaliningrad is a Russian exclave on the Baltic Sea, which is the western side of the Suwalki Gap.
So I think the short answer is yes.
We had a talk this morning about how if you say let in someone to freeze your objects, you weren't quite sure how far the Red Army would get. Anyway.
All right, questions?
Can you allocate in your colors region?
In your colors region?
Yes.
Yes. So if you have.
Can you exclave?
No. So how it would have to work is both functions have to be cooperative, right? So if I have an exclave function and I'm calling a function that itself uses exclave, then that's going to actually use the caller's caller stack. Right, and it's safe to do that, right? Because I have the call stack. You can just look up the stack code. All right. So I promised Alex this this example like 15 minutes ago, but here it is, right? So this code compiles, but we actually would have the same problem as before, because there is a race condition on the increment and the get of the count variable. Right? Atomics prevent data races because of the synchronization, but they don't prevent race conditions. You still have to write, good code in the sense. And the problem here is that the increment and the get should be atomic. Those two operations need to be atomic in order to have a good version of Jensen. All right, so to directly answer your question, Alex, yes, you can write this. Yes, it compiles. Yes, you'll still be debugging. But this is where we get to capsules. So if the atomic fetch and add function didn't exist, we can actually still write a version of Jensen here that does not have a race condition. So a capsule is going to associate some mutable state with locks that just ensure exclusive access. And then capsules are going to use the type system to track some stuff. They're quite complicated, but we're going to see a nice little example here. So we'll read through it together, I promise. So the first thing we do is we create a mutex that is going to guard our capsule data. And when we create that, we get this mutex value here, which is sort of the key to accessing our data. The second step is we then create our data. And we do that with this little initialization function. And here we're going to go back to using the bare reference. So we just return a reference with the integer 0 in it. And then we're going to write our own version of fetch and anchor right here. And what it's going to do is it's going to lock the mutex. We then get our access to that mutex. We access the data inside of the mutex, inside of that capsule, which gives us our bare reference. And then we do our increment, and then we read out the value. And now this fetch and anchor is atomized, and this version of Jensen goes back to being correct. It has no race conditions. Questions?
What stops you leaking access?
What stops you from leaking access? As in, like, could I return?
No, access is a variable. Can I not just write it to a reference outside it?
Can I not write it to the reference outside the function? Modes. So we're going to use, like, this could be at the local node, and so we can't write it into a reference that escapes the function. So again, these modes work together to give us the safety in OxCaml that we want.
So what type is access got here at the
What type does access have here for the Lambda? Truth be told, I have no idea.
So access is just a type and it's actually void.
Okay.
It has no
Okay.
representation. It is just used to make the typing.
Thank
So
you.
it's basically like it's a permission to, or it's like a witness that you're in the correct capsule.
Okay. Yes. The longer answer is we updated this code last night to the latest version of OxCaml and or this morning, whatever it was, and so I'm not entirely sure all of the typing rules here, but yes. Question. This one. Yeah. Question.
Is there OxCaml studlib that isn't based?
Is there an OxCaml standard library that isn't base? I'm gonna defer that one to Chris.
Soon there will be a new standard library in OxCaml called Ox. I don't think that's in the version that's current.
Soon there will be a new version of the standard library provided with OxCaml. Yes. All right. Any more questions? All right. So I have been talking for a long time. We've been humming. We've been having fun, but I've prepared a little interactive activity for you all that you can sort of test your understanding of OxCaml as it currently exists. So you can either go to this URL, which is tinyurl.com OxCaml-ICFP25-activity, or you can scan the QR code. I believe you can do it on your phone, you can do it on the browser. Some people are having network access.
Last name, Canada.
Very successfully.
Yeah.
Yes, I think so. With
But it's just not on websites. Okay.
you seem to be. You got it?
I can do it on my phone, okay.
Nice. You can do it.
Okay, awesome. Yes.
Hopefully it's big enough to read. I think
Quiz,
it should be.
really?
It is a fun interactive activity.
Not a
Way to
quiz.
test your knowledge.
Press next and then it goes to the next question. Right.
It will tell you at the end of all the questions.
Maybe I'm just getting all wrong here.
We're getting more and more wrong. That is something you can do. I've done it myself.
Yeah, I started getting confident, but actually. No.
Yeah.
Sure, it's good. This is invisible. What is it?
Yeah, it comes with rugs.
Oh, but it's fine.
Don't go on.
Creating a website that works everywhere. We're really trying to. Just let us. If we give you half the diagram.
Is do hydrogen bands across the gases. Like I want to get that. No question, but it is set the notes. But it's not respectful, it should have its multiple functions. Does that necessarily imply the molecule is multiple?
So if the parameters of function.
Yeah.
Then it would be portable.
Yeah. Yes, but
Yeah, I
if
mean,
it's like a record.
if it's like a record, so then it could be a pseudo, and
Was then.
as long as the record doesn't have function, it's.
Yeah, then it's.
Then you could say it's portable, and then it's, you know, then it crosses.
So what we just use the function that only.
It's, yeah, so it does apply.
Yeah, in a sense, like.
They all,
common-
right?
Yeah.
So if we just have. to-
Let's go about one copy.
If no-
Yeah, you have to go up to the game brush, switch it.
There's actually comparative.
Yeah.
Either, and so it is, if you prove, there's a few different things which we did. You could prove that the higher. Yes, it's portable,
meaning that the function is part of the function, and then when we type it.
Second.
If the entirety is really.
Second.
Yeah, we do have. On the Johnson side, we actually.
Yeah.
So the first function, so first, implementation could actually say. That's already. Into the free and then. Presumably the implementation is from. So something could still happen. Yeah, so the interesting thing here about this dedication the uniqueness is that along the control flow paths, they can be used as different. So because it belongs in the true range, it's used as normal. And then it's also range, it's used as variable. Those two they are. The primary. Yes, so that T is going to be. Because if we do call it the truth, it need to be utilized. Then if the aspect runs, it gets turning totally. It can be such.
So in terms of these, so you know, when I they can actually infer.
It could, yes, it could.
And then use something.
So broadly, those are. Writing them down is just. Like if you expect something, then you say, I expect this. I mean, it's the same way we spoke about functions.
Yeah.
Right? They're all inferred, but sometimes I get weird in errors. Okay, let's come back together. If you're not done, that's fine. You can finish our activity later if you'd like. But we'll just wrap up. So it's like this was a whirlwind tour of a subset of the OxCaml language. There's a lot more. There's documentation online you can go and read now with your new knowledge. We also have this tutorial posted online. There are code examples there where we give you code activities. Right? We give you some OCaml code when we say make this, parallel OxCaml code, and you might have to rewrite it and add in annotations. We also have, Anil has posted some information in the Discord. So we have a GitHub code space online that you can actually generate. So you don't have to install anything locally. You can just test it out online and you have a working version of the compiler and all of the tooling. If you want to do that asynchronously during the week, you're welcome to. And I will be at the Jane Street booth from 3 to 4 every day answering questions. You can also email me. You could also, if you really wanted to, come back to this tutorial session at 4 or whenever it starts, and Anil and Casey are here and they can help you write code. I will be giving the presentation to a whole bunch of other people, but they can take you and write code if you want. It is there. Thank you very much. More questions?
Just a question. If I'm not writing parallel nor performance critical code, do I actually care about the account?
Do you actually care?
It's cool, but
it's cool, right? So in short, if you don't need any of the properties that OxCaml provides, then no, right? Like there's no reason you have to use Rust if you really want to use C++, for example.
Yeah.
But if you are doing these things and you want this fine-grained control over the performance of your code, then we have OxCaml. And then you can go in sort of the opposite direction. So Rust goes from like systems to safety. OCaml is going from like really safe and high level to the system side, right? So they're taking different approaches on that spectrum.
But it's not only performance, it's also concurrency, right? Like data race and so on. So
Yeah,
even if
but
you
I
don't
mean, if
write
you're not
performance
writing,
code, might still want to avoid data races, I guess.
If you're not writing any parallel code, then it doesn't matter. But I mean, also,
I am finding it quite useful to prototype code in OxCaml, then write it in OCaml without the annotations, because then it's more portable for general use. But it's generally safer because we've used the more restricted types of OxCaml to put you down a good path to avoid data races in the future. So even for purely functional code, it's quite useful.
Can you use effect handlers in OxCaml as well?
yes, we actually saw. So this like await.t, this is sort of like an awaiting capability because we're using the mutex here. So we need that capability because currently we don't have like the types effect handlers, but in the future, when we do have them, that could be just implicitly passed in, right? And then we have the effect handler for awaiting. We don't need it.
Or we can use it right now.
Right now.
Again.
Right now,
Yeah.
yes. So you can go write that code. This code runs if you
As of
write
like
the code base.
we clicked merge about last night. So
Yeah.
there's a brand new version of OxCaml.
As of 12 hours, you can write this code and run. Yeah.
I just want to give you the applause because we skipped over that.
Yeah. More questions? We have them.
Oh, yeah, what we're going on, is that Richard's comment? To what extent is OxCaml directly, which way would it be downloaded compatible with OCaml? So, could you run your code through something that strips out all of these annotations? And then does that still run on the standard OCaml or?
Not if you're using like, well, I guess if you strip out the annotations and the keywords and change libraries and things like that, then yes.
So I think some of OxCaml's extensions are straightforwardly erasable, and some of them aren't. In fact, Jane Street's internal versions of Basic 4 now use OxCaml. We run them through a version of OCaml format that does exactly what we suggested, strip out the annotations before we publish it. Some of the extensions though are not.
Yes. Slightly longer answer is that there's three different types of OxCaml extensions. The first one are things that are upstreamable to OCaml. So there's features like label tuples and things which have actually just been put into upstream OCaml. So they're in OCaml 5.4, released about 3 days ago. Then the second set is the erasable ones, and then the third set are the really hard to erase ones. Things like locals and stuff. You just use local underscore, and then that just becomes an identity function in normal OCaml, and you can just ignore it. But the parallelism ones are super difficult to erase.
The relevance, yes.
Just about the experience using it, the US users. So is that, would you usually write, the libraries that will use them in these features internally, and then at the external module level, you don't need to care much. How's the experience?
I'll defer that to the people who write it. Actually, I have very limited writing to do.
Yeah, I mean, I think there's been a lot of cases of we've went through and added annotations to a bunch of libraries internally. But then there's still a bunch of clients that use these libraries, which have been annotated, but don't actually make use of any of these OxCaml features that we talked about.
So the idea is that you only really need to use it if you want to, and if you don't want to, and if someone else is in their library, then they have to worry about it and you don't. In practice, it seems to play out mostly that way.
If everyone wants a really hard mode kind of problem, we've got this EIO library in OCaml 5, which is a simple kind of concurrency fiber core. And I've just started porting it to OxCaml for fun. So it's a nice way to just re-implement the annotations from scratch in a new library that isn't Jane Street, just to get a sense of how to try it again. So that was interesting that we can just have a go at the fiber core later on in the next session.
More questions? No? Okay, well, more questions.
Yeah, I wanted to ask, to which extent does the effort of porting the internal libraries and porting existing code into OxCaml pay off, and benefits you get from having it roll?
I'll defer. Do you have an answer to that, or should we defer to the
So the question was, to what extent is the effort we're putting into port our code to this?
Yes.
I mean, I guess it must pay off because we didn't just port the code to the new branch of OCaml. We wrote a whole new branch of OCaml to support it. I think it is, yeah. I think it's definitely paying off. I mean, we frankly were not comfortable letting Jane Street software engineers write parallel OCaml programs until we could give them a way to guarantee that they didn't have databases, because that felt too risky to do in production software. And so now we have started to deploy programs that are parallel because they can put them without databases, and we think that's been productions. So despite the fact that it would take us a solid 2 years.
Okay, then one other question. Is this is the development of SCAML going on in a separate like research part of Big Street, or on the, I mean, is it like a
terrific question. The question was, is the development of SCAML happening in a separate research product? And the answer is no. Jane Street has no separate research org. We have a team that works on the OCaml research, but we're not a research team. We are software engineering.
Okay, I mainly was asking how successful are you on like pitching this idea of doing SCAML to the global Big Street people?
How successful?
Yes.
I think we're reasonably successful. I mean, first of all, the engineers use it and they like it. The engineers who are our users report that it is helping them with their day-to-day work. And I don't know, they haven't fired me yet, so I guess.
For those who didn't hear, the consensus is OxCaml good. They're still working on it. Engineers happy. Jane Street, no data races. So check. All right.
It's what, when you're thinking about this, break up OxCaml into multiple pieces. So there's things like the local extensions and memory control and clients for layouts. That's kind of one thing that lets you do things like take advantage of new hardware. So SIMD instructions and vector units and that kind of thing. And then the parallelism is to give you a counterfactual from upstream of OCaml development. It has been really stressful getting people to port their sequential or formerly sequential code to parallel code now. So in the community, there's lots and lots of efforts to make this work, but really it's a lot of dynamic checking and thread sanitizers and that kind of stuff. And so it's really exciting to see the fact that there's also this really brave kind of attempt to bring DRF there as well, right? So that's very much still to be decided if the ergonomics work out, but the end result is completely worth it because we should absolutely be aiming for data race freedom, as a basic kind of part of our language. But parallelism is a new thing in OCaml, so that's only just coming along now. Whereas local allocation and memory control, that's kind of a thing that is kind of always needed, and that came along much earlier and is much more mature in the language.
Why do we need stack and exclave? Can we not just infer based on the tailful position of the allocation?
I mean, for exclave, the thing is that like if there's a library boundary, if you want to keep separate compilation, you can't have it like you're just installing a library that someone else has written, and depending on how it's used by other intermediate libraries that you have, etc., you can't. You would have to do that whole program thing if you want to analyze all the call signs.
Could you not just annotate the return type of the function as local? And this infers the fact that you're always allocating to callers region.
Sorry, I'm just going to move forward so people can hear me. You are actually correct. So in our very first version of this, we only have the stack keyword.
Yeah.
And that meant its meaning was context dependent.
Yeah.
Like in a tail position, it meant exclave, and other positions it meant allocate on the stack. Our programmers found that really confusing. They didn't understand why stack meant some things in some places, and or actually it was local. Why local meant some things in some places and other things in other places. It's also sometimes ambiguous. Like you can have a position that is both an allocation site and a tail position. So we actually did a lot of work to undo that choice and split into 2 units.
Okay.
If the type system can like check if it's annotated local and it's able to check if it's not, and we'll give you a type here. Why don't we just like default to like and make everything local, and if it's near like promote it to global? Well,
I mean, that's ergonomics, right? It's a bit like the Rust kind of choice. I guess OCaml has a GC by default, and then you choose kind of region control for performance critical code, unlike Rust, where you control the things and you build a dynamic allocation library on top of that. Just the opposite philosophy. It is really hard to use if everything's local. in fact, Raphael and I built a prototype of this in 2013, linear ML, and it was beautiful, but unusable.
If there's no more questions, join the Discord, fire up a code space. You can start writing code activities. But thank you so much. Like I said, I'm here all week. Come talk to me, talk to them. They're smarter than me, so talk to them, but you can also talk to me. I'm less than me. And we're all set. Thank you so much.
And the small procedural thing is that if people can't spin up code spaces, we have an organization we can add you to that has a prepaid code space. So just pick us a Discord, it will add you to that org, and then you'll get
No, it's so
Oh, it's not.
I started to sorry.
When does it end?
I don't know.
Oh, you want.
The bigger those say, I said, but I have
My job.
I think some first time like doesn't have so there's some history for by you don't have
Highest amount of also. Which is not.
I don't have the I look up.
like everything that's not part of it.
Okay.
I understand.
Say I use a product, like the customer don't see this guy.
If you don't watch,
No, they're also important. Sometimes. Well, I'm not doing a lot. But yeah. Yeah. It's like a fragment.
So they sort of help and then, so like.
Maybe it's
like, oh, we have cameras or, let's start on this little range. If we want to use like a strict question.
Yeah. I think Louis like the manager.
Also, when I was a kid, we frown on the skin on these books. Grammar, but I didn't know this burning.
Yeah, also I think that's part. Even if you're from Argentina, Brazilian, then Brazilians and Portuguese between each other. There is a joke like this.
Thank you.
It seems to be
was not.
It's very annoying. But to you, I feel that you want to.
Yeah.
I mean, the Portuguese running. I think I feel it's
The drawing
The other way around how you use like your tools.
Yeah, like, for example, I have diagrams.
I can kind of make understand
Spanish process like
people who try to
You can-
come across.
I also have the impression that Spanish people will do their best to not understand Portuguese people.
But this is more like-
They do not understand that.
It depends on, I mean, if you're going on holiday, they're going to insist they want.
Yeah.
So they are like, the American is very Spaniard going outside and insisting they want to be.
So you can add, like, after you talk about that, so for example.
Don't worry, I didn't know whatever.
When I call this functions like applications.
Whatever, and looking somebody tries to use it.
It's not using. Like, it's
Yeah, well,
So
I'm
you
not sure it was the old
install,
attention.
and you use the camel expansion, you're gonna use the optional version of. And like, we only include the library.
Yes.
So you like, you just internally, like, we import some unsafe things and then we add our annotations, and then sometimes.
If you lose these types of like, you kind of don't know.
Then that's fine, because the annotations are correct.
In theory, they're like.
Isolating the list of consultants
Some.
from the other. They are really taking, I mean, does it have some other?
That's what you do.
Demos are.
It's probably gonna fail.
In short way to answer the question is
They
like,
know stuff that they're going to do.
no, if I'm doing crazy stuff, using stuff with libraries. But if you're just using aux camels, you get.
Here's my question, like, about because I'm imagining a world where there's, you can sort of say package and then say package within the same window. And then the like, we have a lot of things and everything gets streamed in there, maybe not every package will have annotation.
So that would just be the version of OPAM that only expresses.
Yeah, so if you live in that world, fine.
Maybe you live in that world, you're fine. Right, I mean, it goes back to James' problem, right? If you just download an annotation for library, you don't know, you don't know if it uses some crazy unsafe code. Destroy your.
That's probably.
There's no way to know.
I think also.
What would you install?
There's always time. In the same.
Right after that.
Yeah.
It was a.
Well, if you have like.
The other are going to be.
A library that only.
You know.
I don't think so.
Yeah, because there's no parallelism and.
Systems, there's no stack application, there's no all the things that we actually.
In a way, that's the issue, because then if you have mixed programs with everything, you're like, oh, this is probably fine because probably doesn't use parallelism, and maybe one time it does.
Presumably, if you care about actually your whole like program system in one stage, then you would use the subset, like have some mechanism for seeing the subset of your
Yeah.
And. Yeah.
Change a few things, basically it's a simple way to have.
I was like, I don't know.
And then it goes down. The new guys are actually getting you guys.
Something else.
It could just be some open like metadata saying like intended to be safe.
And it's going to be the. Ensuring conformity by next year, which is difficult. Have a second level.
Or less. Understand atomics as something that does.
Not just meaning, but actually engineering and actual code, that's my big task force.
I think.
So,
yeah,
it's but we're getting things.
Using.
Against
Give intended value to the atomic.
You can take it in the topic, so there's no consistency.
It's close enough commitment.
Yeah. So.
This is the thing, I'm curious from the perspective of someone who's like at our your level.
Well, I'm just trying to live or something. Yeah, I can't do nothing.
I first, yeah, because I'm currently debating switching to.
Okay.
It's very minor. It's
So this is, okay, this is interesting. If I have an atomic something. I can really beautiful. Yeah. Right.
Sorry, an atomic, what do you mean by like a record in an atomic, or do you mean?
Record in.
Okay, so yeah, if you have the atomic uncontended, and you get the record, you get the atomic contended, and you get a contended record, and then you can do the normal contended.
Normal contended.
Like, at least for the case of like, yeah.
It's actually a good question. I mean, you're now making me question.
Hey, how's it going?
I was feeling confident in my initial answer, but now I'm not sure. What, yeah.
Sorry, can we slow that?
You may. Also, where's my?
Hi, I have a minor administrative thing.
Okay.
Which is really a tutorial, which I have a structure for healthy.
So since OCaml has the uniform value representation, so everything is either an immediate or pointer.
Yeah.
It means that you can uniformly represent anything into an atomic just for STM.
Oh,
So like a list into atomic, for example.
the part of atomic, like if you change the actual pointer.
Yes, it's a pointer to something.
Yeah, okay, okay.
I only have a computer, so that is.
Which is so nice to have.
But then you don't have like atomic like read and add just doesn't make sense. It's not insane.
Correct, yeah. So the like fetch and add is just on in atomics, but we also have functions over to get atomics.
Which can be like get and
Yes, I
replace
actually
with
did.
another value or something.
So yeah, you can do get, you can do compare and set, which checks if it's physically equal and then sets if it is. And if you combine those two, and then like do a loop until it succeeds, then like you can kind of get safe behavior of like an atomic like update
Yeah.
for compensated structures of lists. And so we, with like the version that we have in our libraries has a built-in function called update that does that loop of keep trying until it works, but like backing off iteratively.
It's only 7
mod resources.
Oh, okay, I do remember seeing this.
Okay.
Yeah, so we just want to say 2 things once, there is.
That sounds complicated.
It's, I mean, oh, like,
How you get.
I don't know, this is like the fundamental way that we actually implement a lot of things. It's like super useful to be able to just like take some complex immutable data structure and
I
then
never
program it
noticed
to atomic,
they were moving
and then do this
everywhere.
update from it to like have your like to update your system's global state and like make it safe. And it just works and it's like very nice.
Are you aware of that happens?
Yes. I think we are gradually importing stuff.
We were
But that's-
using like still in queue with.
But we'd like have to do some work to like add the annotations to make it safe.
It should be safe, but maybe also maybe it's safe in a way that doesn't work with the annotation. Like, you know, because when you don't have typing, you can have like things that are safe but are like a false negative or something.
Yeah.
We've just made the interfaces safe.
Oh, and you can just say whatever actual magic. Yeah. Is it really magic function to change modes?
Yep.
There is a separate, there are multiple magic functions now. There's like a
Okay.
magic portable,
Yeah,
which
just-
takes something to its.
Yeah,
makes it portable.
because if you just
Yes.
use object magic, then you don't even know it's an actual type.
Yeah.
Sounds like a bad idea.
We have specific.
Yeah, and the LFO that's starting is pure sine wave. It's a pure sine wave that then feeds the pitch scaler into a triangle and they're envelopes, but they have slightly different ADSR. Also quantized envelopes. I don't the output that makes the sound, but the LFO just never stops. Always gonna generate notes.
Yeah. So good, but see that.
That was one, that's not the one I'm thinking of, but it was. That's so much fun. Hey, yeah, that's right. Oh, yeah.
On the channel, yeah. I think so, I don't know.
Yeah. Really. So cool. This is kind of in the scale of like near array.
Yeah, it's in a briefcase.
Yes. I think it's something that form factor finally like kind of came out, has been taking over because, you know, it actually means like I'm starting to see like at least in my area, some DJs will bring little small sets. Nothing crazy, but it's like I just want to be able to add something to what I'm already, you know, the set that.
Yeah. That'll work for you.
Some of that, yeah, and then sometimes just to give them extra texture, or even just like a new instrument layer to add on. So for certain songs, they'll have like patch setups or like, oh yeah, no, this is like another instrument for this 3-track thing. So, yeah, but then yes, also as an effects pedal, I've seen gotta do that because sometimes the effects that are on the mixer, if you know how to use them right, sound really organic, nice. But a lot of times if you kind of jam stuff in or get too aggressive with it, it's just super cheesy.
Yeah.
It doesn't feel very musical. It feels good.
Yeah, I don't have a lot of muscles, no, probably, but one kind of those muscles. There's like different ways to make filters.
They all sound different, and yeah, the Allen Heath filters are second to none, and then whatever Pioneer shoves on there is the digital one. You're always thinking it's just too digital. On the newer mixer, the 1800s.
Aside from noticing that I'm also a big user, I actually did have my own sort of semi-related question. And also wanted to crack on.
Let's mostly. Is
that still a copy?
Yeah, because we're copy break. There's one more section for all the others still.
Oh, sure, but I mean physically, like, because I think it replaced.
Those for lunch.
Oh, there's a mic.
It's also the room that I have.
So we only two rooms,
So
we only two rooms.
That's fine. This is.
Well,
I don't know who's in that room, but maybe we only have one room then.
Oh, was there someone in there?
Something was on the screen.
Oh.
It looked like, I don't know if it was Casey, it wasn't Neil, because we were just.
Yeah,
Um,
okay, yeah.
Yes. It is.
Yes, it is.
Let me. So. This thing.
Here. Yeah. Me too. I really. No, me too. The only part about Sam I know is I loved it. That's tough. I know most of those.
Oh, yes. Our.
It's gonna go so.
So is this a replay of the tutorial from the last session?
This is a replay from the tutorial from last session. I believe you were not there, right?
I was not.
Okay, we actually have an alternate version for people who came to the first one and want to program live in the second one. Allegedly, I don't know where that's happening though.
Okay.
So I can't tell you. But this is, if this is your first time, you are in the right place and it will be great. And I need to join Zoom somewhere.
Is somebody in the other calling people to come here?
No.
Someone just did, but other people may be going there.
Wait, that's the worst. That's the worst. Next. Sponsorships from digital. You said that. I agree that you should be really upset with that, given that you intended to go into the last 5 years. I think it's a bad it's from his family. Our song. It's small record. The building you're writing about TSM.
Oh. No, I was wondering, but I knew someone would come back, so that's great.
I have the look, I love this shit so.
Oh
my God. It's that thing, you put it on the subway, the thing that says like you can bring us $500 fine. It's very, it's various fines for various things, and it just says no variant. There's no fine, it's various. By the way, that's for a second. It's gun. Oh, God. It's illegal to sell gun, but not to us. Are you sure about that? Are you sure? Yes, right here, officer.
So. I forget your name.
When I was in.
It says that I can't join the meeting because someone else is in the meeting.
They thought it was gas.
Where's the hot?
Yeah.
It says the host has another meeting. I wasn't sure if I should leave.
Okay, what I can do, I either invite you.
Yeah. And Neil, do you have other people?
I don't have any. I put them on Discord.
Okay.
Do you have email active? I can maybe email you a link, an invite to this meeting directly.
Yeah, you can do that. So it's.
It's good.
Yeah.
So. I remember run out of
I've
actually been able to keep it in my mouth for long enough to tell. Because my body rejects certain, I think maybe it's an acquired test. Do you remember?
Yeah, no,
You can connect to the HDMI, I think, and it should. It should work. I'm gonna bring up that.
It's if I do this.
Is it bringing it up on?
No, it's just a Zoom.
I'm gonna call, so I can.
No, I wouldn't say that.
Products made from actual. Because during ice cream, it's quite good.
It's almost like you have a good job. It is true.
I love that space.
I can read that. That seems like it's just you kind of lose that.
And it's possible to do.
Is there any way for me to get my screen out there though? Because I do need people to fill out a quiz.
Okay. I'm not supposed to do this. Is this how we messed up the thing last time? But
if I say laptop HDMI?
Yes. I honestly don't know.
They didn't do anything, so. Oh.
Yeah. So.
It's roughly the same thing as everything.
Just while we're waiting for people, because I do want people to fill this thing out. While we're waiting to figure out the room stuff, Zoom, there's this QR code you can scan and let us know why you're here. I think we can join the meeting again.
Sorry, I thought that was.
He's trying to join the Zoom meeting, but he's saying that he's busy with like another meeting, like he's not joining this one.
I might need to get someone who knows the infrastructure. Okay. Which meeting is it running? Like a completely different one?
They had to set up a new meeting here, I think, we removed from the winter.
Okay, sorry.
When he tries to use their credentials to log into the Zoom meeting, it's bringing up a pop-up saying that
It says the host has another meeting running, so you can.
What is this one?
Oh, I connected it because I have a quiz that people were doing. And so I can. 830 join. And the meeting is. There we go. So it says host has another meeting.
Okay.
Host has another meeting in progress.
So it all is like.
Oh. This is what.
This
is from.
Also, he and Ryan are members.
That is from this. This is what you can, right? Thanks for showing up. Can you go check the other? See there from? Yes. Oh, which one? The with the recording. Okay, with the recorded presentation.
Now we're all here.
There we go, finally.
I'm still not seeing the
I think it should be recording anyway.
There we go.
Okay, good.
Okay, so we're set up. Finally. All right, welcome everybody. We can officially get started. So welcome to OxCaml. We're going to be talking about this oxidized version of OCaml. And the first thing about the language is that it is a bit in flux. This is not like a finished product.
So what our main goal here is to give you an idea of what the essence of OxCaml is. So as the language develops, your mental model of how it works stays the same, and you can work in the language throughout the versions. Now, this tutorial is also a bit strange because we're going to be interactive and I'm going to be asking you questions, usually like poll questions, and you're going to vote by humming, right? Presumably you all know how to hum. So we're going to practice really quick. Hum if you know your neighbor's name and where they flew from. This side was very weak. Okay, so we're gonna do 30, we're gonna do all of the J Street people over here. So we're gonna do 30 seconds. Introduce yourselves to your neighbors. Tell them where you flew from. If you don't have a neighbor, have one because they'll be very helpful throughout this tutorial. Go. Okay, let's come back. Back to the front. All right. All right, so now you should know your neighbors. We're going to try this again. Hum if you know your neighbor's name and where they flew from. That's good. That's much better. Very, very loud. I like a good strong hum. Like have some conviction about your answers here. All right. So, what is OxCaml? Here we're going to describe it as providing safe control over performance critical aspects of program behavior in OCaml. Now, it's a lot of words, so let's sort of talk about some of them. Control. What do we mean by control? Well, control over things like memory allocation and memory layout. Typically you'd associate this with a systems programming language like Rust, but we're coming at it from OCaml, this high-level, beautiful language. We're going to add some control to it. Now, safe. We mean data race freedom and memory safety, right? If we have control over memory allocation, we want to avoid things like dangling pointers and accessing dangling pointers because we've programmed in C++ and we decided that was a bad thing to have. So we want some safety here. And in OCaml, meaning that OxCaml is a superset of OCaml. So every OCaml program is a valid OxCaml program. You can take it and you can compile it into OxCaml. It might not compile if you have something like a data race, but we'll talk about how you can fix that later. And we're going to start with safe stack allocation. And we're going to use this running example of GenSim. Can people in the back read the code? It's a little smaller. It's a little small in this room. Barely is the okay. That is only making okay. That didn't work. So if there's an open seat in front of you, feel free to move up. I don't know why this room is so much smaller, but this is going to be our running example. By the end of the 90 minutes, you'll never want to see GenSim ever again. So we have our count. We have some mutable reference, and then we close over that reference, right? So we have our mutable reference here, close over it in this lambda here. Inside the lambda, we increase the count. That's right here. And then we append it to this gsim string, and we return our new sim. Now, of course, GenSim is always going to provide unique symbols that our compiler and other programs can use. All right. Now, I may have some performance critical function here that I write, and that function for some reason might need 2 GenSims, and we put them in this array here, and we bind them to this variable symbols. Now, for our first poll, here are 2 diagrams that might represent the state of memory after we've bound the symbols variable. Talk to your neighbor for 30 seconds and decide which one is accurate for OCaml. Go. And discuss with your neighbors.
Question is whether you're going to figure out what these don't you go on. I'm pretty sure. My guess is that Campbell's gonna.
Don't give away the info.
No, not going. Well, right. It's difficult to. This is not even showing where the. It's not even showing where I think it's Camel could, even without the super speed things, Camel could put. How many people agree to do it? They could put a stack. And treated it so.
All right, let's come back and let's vote. Let's come back, pick an answer, have left or right, have one in your mind. All right, so if you think the left diagram represents memory after binding symbols, hum. Okay, if you think the right diagram represents memory, go ahead and hum. All right, so why is the right one, or why do some people think the right one is the state of memory here? There were some hums. Anybody, what did you guys talk about in your groups? Yeah?
Well, if you don't return symbols, then you put that on.
Okay, there was a qualifier there though. If you don't return symbols, then you could put it on the stack. I haven't told you what I do with the function, so it could. Okay, anybody else? Jonathan?
So I was guessing the left for other reasons, but
Okay.
to steelman the right, I think symbols is not mutable. So I can just copy the tuple. I can copy the tuple of symbols whenever I want to.
Okay.
So I can just implement it as a value type.
Okay. These are some good answers. Anybody else? Did anybody mention something? And any reason for the left diagram here? Nobody, people are now skeptical of the answers. There's a half hand in the back hand here. It's the most straightforward implementation. Right. There, Jonathan?
And it avoids the copying.
And it avoids the copying, okay.
Multi-word value.
Multi-word, okay. We're getting technical here. Anybody else? No, the answer is indeed the left one. Right in OCaml, these are all heap allocated values. So when we create the two strings on the heap, when we create this array, also on the heap. Now, there was an interesting point over here, which is I could stack allocate them in theory. And why would we want to do that? Right? Given this memory, given that we make these allocations here, given the really good name of my function, what bad thing might happen?
Stop the world.
Stop the world, meaning there's a garbage collector, right? Someone has to clean up these allocations. And if we make a new allocation, we might need to clean up some others. And so we're going to run the garbage collector, pausing our program. And now all the money I was trying to trade is pausing, and then I make a bad trade and I lose a bunch of money, hypothetically speaking, in this performance critical function. So we have a garbage collection cycle there. So, Richard.
Indirection.
Indirection.
As in, that's another bad thing that can happen.
Another bad thing that can happen. Yes, just it's slower.
It's slow.
It's slower. We have to go follow another pointer to get to our array, follow another pointer to get to the strings. Another good point. So if we want to avoid the heap allocations, what do we need to do and or know to safely avoid them? There was a point over here if you want to repeat it in the green shirt earlier.
Well, you need to make sure that you
symbols doesn't, the lifetime of symbols doesn't like extend past the like end of the scope of the function.
Lifetime, what is that? That's a technical garbage. Another way to. Lifetime's a word that doesn't exist in this room. So another way to say that is we're going to perform in a more compiler-oriented ways. We're going to perform an escape analysis, right? Does symbols escape the function perf critical? If it does not escape the function, then we could locally allocate it. And then if we actually want to locally allocate it, the second step is we update the allocations, right? We rewrite that code to do a local allocation of the array instead of the global one. All right. So OxCaml provides facilities to do both of these things. The first one is the escape analysis. So if I take this code, I can now say, I don't expect symbols to leave this function. And so I write this @local annotation here. And I am telling the compiler, hey, I expect that symbols does not escape this function. And then the compiler will check whether or not I am right, or if there is an escape. So if it does, it would give me an error, and we'll see an instance of that later. But every value in OxCaml is either local or it's global. Now, global is the OCaml default, right? Because values can freely escape their functions. We can store them in references and global hash tables, etc. But if we want a value to not escape the function, we can assert that it's local. And this is checked by the type system. Just said that. And then the key thing being is that if a value is @local here, it could be locally allocated. This is that escape analysis where we're asserting that symbols does not escape the function. So that's the escape analysis, but how can we actually ensure that symbols is locally allocated? Well, OxCaml provides new keywords to control these allocations. They are stack _ and exclave _. We will get into how to use those in a second. So using stack, we prefix this array expression with the stack keyword, and this tells OxCaml that, hey, the allocation that occurs in this expression, I actually want that to be a local allocation. Now, I also have the @local annotation on symbols. I could remove it, and the compiler would infer that symbols is local because we've used stack. And then that is also statically checked by the type system. All right. I've been very careful to say local allocation instead of stack allocation. And the reason for this, I'm going to use Rust to illustrate it. We're not going to say lifetime, but we're going to use Rust. And the reason for that is Rust makes explicit what the OCaml code is making implicit. So in every function, there is this local allocator, just like a local arena allocator. And so when we say stack _, it's actually going to use that local allocator to allocate the array. Now, when we return from the function, here, like at the curly brace, or when we just drop off the end of our code, that local allocator gets cleaned up and the memory is all freed from it. Question?
Is that memory?
We can discuss specific implementations later because I don't know actually how to answer your question, but you can think of it as a separate region, not on the direct call stack, because it is a dynamically sized piece of memory. And so, yeah, when we use stack, it goes into this local arena allocator, and then that allocator is cleaned up when we return from the function. So I've given you sort of a half view of how the system works, and I'm interested to know what you guys think the state of memory is now, given sort of the partial knowledge that I've given you. Is it the top diagram or is it the bottom diagram? Discuss with your neighbors.
Yeah, I mean, like gems and the only question is all it has to be for tiles. Yeah, it's not just it just makes the
But that's, we haven't done anything to save the other.
All right, let's bring it back. Pick an answer, pick a diagram, be confident. All right, so who thinks that the top diagram represents the state of memory now? Okay. Who thinks the bottom diagram represents the state of memory now? Conviction. It's hung with conviction. There is not a third option. I only prepared these two options. So you're also humming for the bottom one.
Sure.
Okay. Why would the top diagram, for all the people really who strongly believe it's the top diagram, why is that the state of memory? Anybody want to?
Jensen doesn't use exploit.
Okay, that's using a lot of technical terms. I don't know. Anybody from this side of the room? I'll just ignore that side. There are a lot of hums, yeah.
Whatever Jensen could be returning could be already owned by something else way back in the GitHub.
All right, right. Jensen is doing the allocations for the strings, and we don't know anything about the implementation of Jensen. Yeah. So you are correct. It is the top diagram. And that is because stack underscore controls the allocation only for the array, right? In this expression, the immediate allocations in that expression, Jensen still allocates its strings on the heap. And as it was said over here, we don't know, well, we do know the implementation of Jensen because we saw it, but another implementation of Jensen can do whatever it wants with those strings. And we can actually deduce this from the type of Jensen itself. So Jensen is a function from unit to string. And as I said, every value in OxCaml is either local or it's global, and the default is global. So another way to read this type signature is it returns a string that is at global, meaning that it is not locally allocated at all. And local allocation here requires cooperation from all of the callees. So if we wanted everything to be on the local region, we need to rewrite Jensen in order to cooperate with that design. And now I'll tell you exactly how to do that. So we can sort of abstract our function of creating this array into a helper function called Jensen2, which you might want to do. And this code now no longer compiles because it says this expression, right? This expression is not an allocation site. Calling that function is not allocating anything. So using stack here is just wrong. It is an error, and the compiler is telling us that. Okay, so we might move stack up to where the allocation is happening. Question? Yes, so at local, we'll get into exactly what that is in a second, but that is specific to OxCam. That is that escape analysis in the type system. Right. So we could move stack up here where the allocation occurs, but now we get a different error that says this value escapes its region. Right, and we can illustrate this sort of with the Rust code again, because we have this local arena allocator. When we use stack, I said that turns into a local allocation. So we're now returning a pointer that points into the local allocator. But when we return from the function, that allocator and all of its memory gets destroyed. So we would be returning a dangling pointer. And I forgot to mention that all of these confused ox camels are going to mean that the code doesn't compile. That will show up throughout the presentation. So stack allocates the array local to gensim2, but what we really want is for it to be allocated local to perf critical. And in order to do that, we use the exclave underscore keyword, as was mentioned earlier. And so what that is going to do is it's going to say allocate this in my caller's local region. So now when we call gensim2, the memory sort of looks like this. And when we create that array, it's going to point, as we can see, into the local region for symbols. And we have this horizontal bar sort of noting the difference between those local regions. And then when we return from the function, the array is still intact in the local region of perf critical. Question?
You also pass the pointer of region to.
You can think of it as doing that. You can think of it as walking the call stack and finding the pointer to that local allocator. The implementation details are a little fuzzy, but that's how you can sort of think about it. All right. Now, here's a separate variant of this gensim2, or allocating the array on the stack here. We're now going to be using a tuple instead of an array, and we still have stack. And this code, of course, doesn't compile because I'm returning f, the first element of the tuple, from perf critical. And because we're using stack, that is going to be a local allocation. The compiler thinks of it as a local allocation. So the first element of that local allocation cannot escape the function. But if I were to use genint instead of gensim, which is sort of gensim's cousin, and then we return the first element of that tuple, this code actually does compile. Does anybody on this side of the room want to take a guess as to why that might be the case? Right? Why is this right code safe, but this left code is unsafe?
Because it's unboxed.
Because it's unboxed. Integers aren't allocated, right? So if we return an integer at local, it's still just the integer value. And so integer at local and integer at global aren't meaningfully different, right? The property of the integer in OCaml is that it is unboxed. Perfect. That's just what I said. Now, you may, question, John.
Yeah, I'm confused by that because
Okay.
I think we said before that the gen sim or gen string version was going to allocate something on the global stack. Are you assuming that you put an exclave in there?
No, so we have not yet changed the implementation of gensim. So from the view of the type system, right, this is a tuple with two strings at local.
Yeah. Okay,
So-
but we've pattern mapped, so we've gotten rid of the tuple.
Okay.
Like F doesn't have the tuple anymore.
Okay.
That's my mental model.
Okay,
Is that
so
wrong?
there's no tuple anymore, but F and S are still thought of as at local because we've used the stack underscore. We'll get into exactly why in a few slides. But you can hold this question in. All right. So to finish up, you may want to write a function and check whether or not it is truly zero alloc, right? That no heap allocations have occurred. And so OxCaml provides a set of extensions to OCaml. One is this @0alloc attribute that you can write on your function. And then there's going to be an abstract interpreter that walks that code to check for allocations. Now this code does not compile because we're using array.init. We've now changed gensim2 to gensim_n, and we're using array.init to generate that array. And that function may make a call to camel make vect, which allocates on the heap. So we have to specify that we want a version of array.init that returns a locally allocated array. We would do that in the current version of OxCaml using this @alloc stack syntax. So that's going to pick a version of array.init that returns a locally allocated array, and the standard library and the base libraries in OxCaml are annotated and provide implementations for these for various functions. Now, of course, this code also doesn't compile because we haven't updated the implementation of gensim, but you can talk to me later and we can work out an implementation of that. All right, so far for OxCaml, we've seen keywords like stack and exclave that provide some control over memory allocation. We've also seen these new annotations @local and @global, and these things can appear in let bindings, right? We put this on this let binding here, but they can also appear in type signatures, like the type signature for gensim2, which returns this local array, or the array.init function, which returns this global array. But local and global are instances of what OxCaml calls modes, and modes are how OxCaml provides safety. So in OCaml, there's all of these values. And we've decided that it's nice to group values by types, right? So we would say that these things on the left are strings, and that there's integers and floats and lists and arrays. And types tell us properties of the value. So in OCaml, strings are immutable. And then we also have a list that describes the shape of that value. And then you might have a list of strings, which gives us more information about that value. Now, modes similarly tell us properties of values, but they're properties that make sense across types. So for example, I might want a locally allocated string, but also a locally allocated float or an array. And that property of local allocation makes sense across the type boundaries. And this blue bubble, I could have drawn around any subset of those values depending on how they're used. So our definition of a mode is that modes are deep properties of values. And then take just a few seconds and read the rest of that paragraph. So going back to your question, Jonathan, this deepness of modes is actually what prevents that code from type checking, because we have the tuple of strings that was @local. Now, of course, we get rid of the tuple, but because modes are deep, the compiler assumes that those strings are also @local because of that deep property of modes. Does that make a little bit more sense?
A little bit more, but we said that they're not actually local, so I still have questions.
They're not local because... One more slide. All right. So some example properties of things we might want is that a value doesn't escape the region. We've seen that with the local mode. We might also want to know that a value is unique. There only exists one reference to that value. That a function can be called on any domain. Here that's synonymous with thread. And that a function can be invoked at most once. One callable function. And there's, of course, a lot of other properties we might want to know. And there are modes, and apparently more modes coming out to describe more properties. Question? Can you be polymorphic on a mode? In the current implementation of OxCaml, no. Current, changing language, future, maybe.
Yes.
Yes. We have a strong yes from Richard in the future. All right. And then the key point is that modes provide the safety to OxCaml. So data race freedom and memory safety are all checked by this mode system statically. All right. So to provide the local and global modes in a bit more of a formal sense, we call this the locality axis. And this axis has two modes, local and global. Now modes, similar to types, there's a sub-moding relationship between the two. And here we say that global is a sub-mode of local, using this syntax here. Now, this is why the code from earlier could type check when we have gensim2 that returns a heap allocated array, but we assign it to this symbols, which is at local, because a value at global submode of the value at local, right? Because local is just that escape analysis portion. We say that symbols doesn't escape the function, but it's still safe to put a heap allocated value in that place. And that is why the code from before type checks. All right. The at local here is a mode annotation. And on all of these slides where I provide axes, I will bold in the mode that is the default for OCaml values. All right. Now, just so that. Now, the reason that the integer can escape the function from before, we said, is because integers are unboxed. That is a property of integers in OCaml. And so when modes and types sort of work together, that is, the properties of the type uphold all of the safety properties of the mode, we say that the values of this type mode cross. So here, integers cross locality, meaning we can return this integer at either local or global, and that is fine. Questions? All right, so before we get into the other axes, let's take just a quick 5-minute break, and then we'll come back. There's like a 2-minute break, really quick.
It's just because it has piles one session and then very yeah, that's just a lot of things, but you know, I would like
All right, let's come back. There's they are online. I don't know if there's a post anywhere, but we can post one in the Discord. Yeah. Okay. All right, so let's go ahead and come back. We're gonna now move into parallelism and data race freedom. So OCaml 5 introduced parallel programming, true parallel programming with a multi-core aware runtime and effects. That's incredible, right? I mean, we've been waiting for it for decades, but we're there. But it also unleashed chaos, right? So now we have data races and these race conditions and non-deterministic bugs, and it's very hard to reason about code. And so now if I'm running my code in parallel, I'm not quite sure if it truly is safe or if I've made a bug somewhere, and then I'll find out at runtime and then debug it for hours. But OxCaml introduces two mode axes for data race freedom, that is the contention and portability axes. So here's our GenSim example again. And what we've done now is we have a version of GenSim N that creates a new parallel array with all these values. Now, the parallel array is going to evaluate this lambda here in parallel for all of the elements. Now, discuss with your neighbors for 30 seconds what sort of bad thing could happen if we call GenSim N with n greater than or equal to 2. Go, discuss.
That would be like a read edit. I'm assuming that it comes out from like you're trying to save applications to subtype. I mean, like once you put something in we have a way of like, I don't know, do you talk about the global modality?
We don't talk about realities now.
So,
let's come back. Sorry, we can continue this later. It's a good conversation. All right. So, can someone tell me what they talked about with their neighbor? What could happen if we call GenSim N with an n greater than 1? Nothing.
Might not be unique.
It might not be unique, right? GenSim is supposed to provide a unique symbol, but now they might not be. And here's a little diagram. So we have, domain 1 here on the left. I'll annotate here. Domain 1 here on the left, domain 2 on the right. We read in domain 1, value of 0, okay? Domain 2, we also read the value of 0. They both increment. Now we have a 1, and we get an array with GSIM 1 and 1. Bad. That is unexpected, and maybe my code later doesn't handle for duplicate symbols because there weren't supposed to be any. All right. So fundamentally, it is unsafe to run GenSim on multiple domains. And so we want to statically prevent this from happening. We want to statically say, hey, GenSim is unsafe to send across domains. And this code, if you didn't see it, red box, confused OxCaml, doesn't compile. So that's good. All right, so a data race requires 4 ingredients. The first is, of course, parallel execution. We do need 2 domains running in parallel. There needs to be some shared domain or shared memory accessible by those domains. There needs to be at least 1 write, and there's no synchronization on the memory that is shared. And if we look back at the GenSim function, right, we have the shared memory here. That's our ref. It's a bare reference, which does not provide any synchronization. There's a write here. There's also, a read here and a read here. And then there's the parallel execution because we're using the parallel array. Now, another way to say this is that the lambda, that's this lambda here, this function, must be safe to share across domains. And then GenSim must also be safe to share across domains because it's called within that lambda. But GenSim closes over this non-synchronized mutable reference, reads from it, and writes to it. So therefore, GenSim isn't safe to share across domains, and neither is the lambda. Now, we'll see how OxCaml actually does that statically. And there's these two modes for parallelism, like I said. The first is portability. And the question that portability asks is this value, really is this function, safe to share across domains? Question here.
When you said like domain, should I think of it as like threads?
Yes. So for the current mental model, domain, thread, synonymous. Yeah. So there are two modes in the portability axis. The first is portable, meaning that this function is safe to share across domains. And then there is non-portable, which means the function is not safe to share across domains. The default is non-portable, and the property of non-portable functions is that the value isn't shared across domains. Now, this code here doesn't type check, and we'll see the error for it in a second. But we have effectively annotated GenSim here saying that it needs to be portable, but it actually isn't. And the reason that it needs to be portable is if we look at the signature for the parallel array init, we have this @portable annotation on the function here. Right. The second axis is contention. And the question it asks is, what access do I have to this shared memory? And there's three modes in the contention axis. The first is uncontended, the second is shared, and then the third is contended. Now, the property of a contended reference is that the value isn't read or written to, and that's because it's contended and multiple domains have access to it. Now, it's also assumed that if I have a contended reference, someone else might have an uncontended reference. They could be writing to it because, right, there's no property here for uncontended. Someone could write to it, could read from it, and we don't know that. So contended, you don't have reads or writes. The shared mode says that a value is only, the value isn't written, sorry, it's only read from. And that's because it's shared amongst a bunch of domains, but none of those domains have uncontended access to the value. All right, now I'll shuffle these rules around a little bit, and then we can look at the critical rule that ties these two mode axes together. And that rule is that references captured by portable functions are contended, because that captured reference can then be shared via the function across multiple domains. And the error that we get with this code is that count, right? We say the value is contended. That's because it's captured by a portable function, but it's expected to be uncontended because we're reading and writing to it here. Any questions on that? Yeah.
Can't it be shared?
Can't it be shared? Can it?
No, I think my question is like references captured by portable function. Can't they be shared? Like everything just
You could, like if you have, for example, an immutable value, right? We'll talk about immutable values here in the context of contention in a second, but people can read from them, yes. There's the answer. All right. So we might want to actually use, mutable state and shared memory amongst domains. And so OxCaml provides facilities for that. The first is atomics, and the second is a bit more complicated, called capsules. So if we take our GenSim function and we rewrite this using an atomic, so we have this atomic here, and then we do an atomic fetch and add here, this code does compile. And the question is, why is using the atomic safe, but the reference was not? What does an atomic provide as a type over references? You can shout it out or raise your hand if you want. No, because right, it's closed over in this function here. And so every thread running Gensim has access to the atomic.
Synchronization.
Synchronization, yes. So because they both have access, it's still fine because that memory is synchronized. And remember, one of the key ingredients for a data race is that there's no synchronization. So an atomic provides the synchronization, and therefore we don't have a data race. All right. And because atomics provide synchronization, we say that they cross portability and contention. So even though count is contended inside of the Gensim function, we can still run this fetch and add because it crosses contention. And so we can increment the value and read from it. Question?
How lightweight is atomic in terms of performance? Do we incur a lot of?
Golly, I don't know. It does incur some overhead, but minimal compared to other machinery that we might have. That's a good question. Any other questions? All right. All right. So we're now going to rewrite Gensim again, but we're now going to call this function make Gensim because we want users to be able to provide their own custom prefix. So instead of requiring that all Gensims have this gsim prefix, they can create their own Gensim function with their own prefix. Now, given the rules I've told you so far, I've said that contended references can't be read or written to, and that any reference closed over by a portable function is contended. But we're reading from prefix here, and I'm going to tell you that this code does type check. It could be heap allocated, right? So there's a pointer there we're following at least. Okay. What's the property of a string type that lets me know? Okay. Uh-huh. It's immutable, right? I could have a string type that is mutable, and it's still just like string.t or something. But the property of the string type is that strings are immutable. So it's safe to read this value because we know that no one's going to be writing to it. Strings are immutable. And so this goes back to the question over here in the front, which is immutable values of immutable types cross contention as well, because we know that via the type, no one is writing to it. So it is safe to do those reads. So for example, if you also had an immutable field in a struct, you could read from that field. But if you had a mutable field in a struct, you could not read from that field. Any questions on this code before we move on? No.
Do strings cross portability as well?
Yes. So broadly speaking, most values cross portability unless they have a non-portable like function stashed inside of them somewhere. All right. Yeah. So we can rewrite this code if fetch and add did not exist, and we get this code here. And this code actually does type check, but is there anything wrong with it?
It's not Gensim.
It's not gensimming, right? I mean, we have this safe code, it does compile, but we've just written bad code, right? There's a race condition on the type, even though there's not a data race. So even though atomics prevent data races, they don't prevent race conditions. And the real thing that we need or want is for the increment and for the read to be atomic. Those two operations need to be atomic, not just the synchronized memory here. And so this is where we get into capsules. So if fetch and add didn't exist, we can still get code that doesn't have a race condition. And the definition of a capsule is that we're going to associate some mutable state with a lock that ensures exclusive access here. And so we'll walk through it, don't worry. We can rewrite the gensim code here to create our own fetch and incur function here. And how we do that is we first create a mutex, which gives us this mutex type here. And then we create data inside of the capsule. And we do that here. And we're going back to just using the bare reference because we are using the capsule to provide the safety. And then when we write fetch and incur, we're going to first lock the mutex. We're going to lock the mutex. We gain access to that mutex. We can unwrap the data. And then we do our two operations of writing and reading. And those operations are now atomic. And so no longer does our code have a race condition. We have a good gensim, and our code works out. Questions on this? Yeah. What is W? So W is a capability of being able to await on something. So this sort of is playing into the effect system that OCaml5 was using. And so in order for somebody to await for the mutex, they need to have the capability of awaiting. Sort of the high level goal is that in the future, when there's, a typed effect system, then this W is not explicitly passed, but it would be, implicitly passed. Modular. It's a good question. All right. Any other questions? John.
I was expecting that C would somehow be tied to the mutex, but I don't see how that's happening. Is that not necessary? Or is it happening implicitly?
So it is happening implicitly here. So the data.create function is actually going to sort of capture this mutex type up here, which tells us it's very complicated, tells us the kind of the capsule. And then when we lock it here, access is like an existential type that tells us there's one access currently to the capsule. Yeah.
Line 3, that pattern match.
Yeah.
There's a essential type.
This line.
I don't see it being used by the next line, though.
It is, it's, if you gave a type definition to counter, it would be there, right?
Yes. Yeah. Unfortunately, I can't show you the type definition, but it would be.
There's some fancy inference happening.
There is some fancy OCaml inference here.
Okay.
Capturing the mutex. Yeah. Broadly speaking, I don't like looking at the types of any of these variables, but you can. That's the thing. All right. Okay, so I have been we've been doing some interactive things, but I've been talking at you for a long time, and we've prepared a little interactive activity for you to go and sort of test your new knowledge of OxCaml. So if you visit this link, there are some things you can work through, and then we have some more coding exercises that you can work on through the week, and we'll talk about those after this activity.
Good question, because I don't know.
Sorry, yeah, first, example in this parallel set, you have like this condition on +1. Yeah. You say it. Right, but let's go.
Oh, awesome.
The same thing we said, every account is from exact.
Yes.
So the resolution that
It was nothing. I'm assuming so. Oh, right. So it's possible. It was. It's not.
So I don't know. Far away. But
That was.
this is the Oxcal array, so it's just, it's still true, you use the Oxcal array. So if you can create. Yeah.
Since I was like. That
Yeah. In some sense, like. Functions. Yeah, very careful of what this is. Like car array needs to require this. Even if we like, we don't have the car array, we worry about that annotation. I don't think anything forces us. Not great, but it always has to be something trusted kernel.
I mean, there has to be exactly what the class. That is offered by. This can be encoded just as their system.
So it uses those.
Okay, but it's not in.
It depends on when you bother recording, but.
Yeah. We might have a formal example.
No, not yet. I don't know if that. Do we know? I agree. The perfect is that we apply to runtime. What's the option? No, I think it's come out in 5.4. Someone's saying no, you're not 5. I think this. I still think most of them. They're different like people. I mean. Oh, yeah. Around here, Meta said that they tried to. But the first problem is this. Yeah.
Yeah. Mac had a huge performance regression. And we just ate it. And I found somebody willing to consult with us for free, come and fix it. And I couldn't go through our EA process, and so we're just still eating. What? The company can only care about 1 or 2 things a year, so
It's so much easier.
for that year.
You guys know that?
Nice.
Yeah.
Yeah, put it on like a board of things we care about this year, or
Kind of in your head.
money.
It's money. Well, I mean, it's not a trading system, it's a tracking system, and you can't just throw more machines at it. It's not crazy, but freeze is such a good. I really.
Are you going to say you were like 5? Oh, come on. Are you at liberty to say who, you said Selfers came by and offered to fix it again? No one.
Oh, I can't remember, it was a member of the panel because they said a regression from our level was a bug and they can find some pilot bugs.
Yeah, it's okay.
And I was like, can they come look at our system?
Yeah.
So, no, not unless you NDA them. And I was like, cool, they can sign the NDA. Like, and what they said, 2 GPPs. I said, well, this will go through the higher base level. Vice president has to sign off. Yeah. 8 to 2 pounds. And then some bureaucrat somewhere decided that the problem would eventually fix itself anyway. It's not true, actually, because it's not like when Hamilton's priorities. It's the perfect time.
I don't.
Yeah. I'm hoping that this is that maybe done probably not for you to speak on and all of us. So the claim of we do nothing, the problem will go away.
Maybe they got it right, yeah, I should have messed it up. They got fired from sitting off. After having everything. Yeah.
Because it's assumed.
Maybe one of the perspectives,
Yeah.
especially
I mean, like.
I like Scamble, but I have a teammate who really likes Oxcam, so maybe we'll just use Oxcam and no problem. Does he change that?
Yes.
Okay.
To the point of like writing the tutorial was a challenge because they are changing.
Rarely keep up with all the changes, making sure our.
I mean, it's not gonna change much this way.
Yeah, we're next week, we're next week, like. Next week, they're like, there are 4 or 5 people, so after that.
So was this, I'm pretty sure you can hold it, grab demo wildly and fake and then. Right.
Was it the benefit for using?
Or not to find out something until the end.
Big problem. So the fix is the fix with everything.
I tried to say, like, for demo. Gotta say. I said, we were the same.
We just use OCaml 4.4.
Yeah. But not, I think we're planning on changing. That. Yeah.
Affecting the words.
Well, I was thinking, how would it be nice? It'd be nice to like, use unboxed types.
Oh, no, I didn't think we were gonna change that.
Why?
Well, it's so hard to do. Like, you know, having no bootstrap problem, having no bootstrap is great. Bootstrap.
We have bootstrap, we have.
Yes, we do.
We have. No, why is that idea? That is my bootstrap.
That's still a bootstrap. Like, how, like when they say, I want a month. No, okay, okay, good. I have an entity. Oh, that's. Oh. I'm going to this for it. No, this is the good answer. The text that converts into regular. No, there's not, you can only use braces. Yeah. And that's fine, there's sometimes to it. Yeah. Well. I mean, I think it's both cool. We can start with this, and then. It's like a gateway drug. But what do we like? We don't even take last question. Yeah. All right. Well, those 5 years last time, and how people. That really just want. I mean, you don't have to convince me. You think it's like that's 6 months. Where did it come from? Yeah, the middle and back and. Maybe it's rather than you. That's where it builds.
Where did you get your name?
I don't remember myself. I have to leave the art classes though. This one's. Oh, that's filter. Yeah, we can't look like it. We should make this lines feel. It's really disappointing. Find us. Why didn't we go? What? What? Extra shuttle. Oh, because we don't want to be too hard. Not every way we're doing it, but what we're doing is different. The figure is cool, but it's not.
You didn't have to change any annotations using the standard language. One of the issues was wrong. That's mistake is the. There's an example word. For district. This is stuff. It doesn't matter. It's what I'll do. Doesn't matter. Yes. Just.
All right, so let's go ahead and wrap up. If you haven't finished the activity, you can finish it later, that's fine. Or don't finish it, up to you. So a quick summary of everything we've talked about. So Anil, I believe in the Discord, has posted a link to a GitHub code space that has all of the current versions of OxCaml and the tooling available. You can easily spin up a code space, and we have actual coding exercises that you can use to practice your new OxCaml development. I will be here all week long, and we'll be holding like office hours from 3 to 4 at the Jane Street booth to answer any OxCaml questions that you have, should you want to do that tutorial. And you can also email me or talk to any of the people that use it in their daily work or work on the language themselves. And thank you, and I can answer any questions that you might have.
You didn't have like a success story of Oxcaml? Like something making 10x.
So I think locals, the locals will be kind of the thing the longest. I think success story is less that they make 10 times faster, and more that they let already done some terrible things. Well, terrible hacks to something sensitive. A good example would be you have a function, right? You want to return variant type, you want to return subtype. The result of your function is either A or it's B. What we used to do at JStream, do this in the latest grading system, but they didn't want to allocate that option because they don't want to risk going to the garbage collector at that point in time. So what they would do is they'd make one subtype whose contents were mutable. So you just allocate one A and one B at the start of your program. Your function would decide to return the A with the content you take, or the B. And like this will work, but it's pretty hard to use directly because you've got to make sure that you've done matching on it. Extract the contents for the next call this time. And so now they just stat allocate an either, and it just looks like normal function. And the old CPUs are in line, right? Like it's just easy. So I think that kind of thing is more of the success stories.
There's also the parallels and stuff are very new. They're like production example. One is like my kind of favorite example is like somebody in a little command line control. The developer wanted like fuzzy finder thing, fuzzy finder lots of stuff. It was painfully slow, and he just wrote 6 lines of applies it trivially. I don't know what the benchmark was, but it was like painfully slow to use before, and just work with it. Like nice. I like that example because it's like trivial. You can solve the problem. There are a couple of other examples that were already highly parallel, like just didn't work well. One is a system where it's like a kind of big parallel incremental graph thing, and basically it was both rewriting it using the shared memory parallel. Both made it twice as fast. A lot more. Yeah. Basically, but also more importantly, there's a bunch of bad heuristics, like grouping pieces of state together in processes, and depending on how you wrote it, there were places where you could not get parallels, and people who wrote expressions that had to do weird stuff to make sure that you could get parallels for weird cases. Like a sort of the underlying implementation exposed a bad. And the new thing is both faster and uses just straightforward work stealing parallel scheduler. There's another example that was also so so and those examples are both all kind of good outcomes and also real work to get them to work, but mostly to quite a lot of the work is propagating of the annoying. And then some of it's just actually figuring out what parallel algorithm. I think the ease of use has been given how kind of insane the actual ease of use seems to be better than expected, although it's hard to know because the people all yeah. I think with
yes, we have solid evidence that you could pretty good programs. I have a couple of good things. One is one thing I like is that I will still get not I think in a conversation with someone they will just mention that they just don't know what locals are and don't know how to use them, and but that hasn't affected them at all. The point is that it's been very pay as you actually use it, so that there are people power users using it all the time and find it very effective, and then a bunch of other people it's fine. They're forced to learn how it works. I think that's one. And the other one I like is the data race. It finds you loads of data races and stuff. It's just filled with the worst code. This global state that you're surely the function with this state will be fine. There's no way to put global state in here, and there's actually so it found a bunch of those, and that was pretty valuable. I'd rather find it that way than find it by production.
Yeah. There's a question over here.
Yeah, it seems like there's a risk.
Started to see that.
I'd say largely no. I'm a Rust person personally, and I haven't requested any features yet.
Yeah, I think
We'll
our
talk
actual
later.
users inside the company are mostly not Rust.
Yeah.
I don't know what they're missing.
Yeah. There is a bit of a different paradigm, right? In Rust, it's nice that it's you always have everything safe all the time. And it's, I don't ever opt into something, I'm forced to use it. Whereas in this sort of ML, oxidized ML style, as Leo mentioned, I can not use one of the features and it won't really interfere with my work. And so that's sort of a nice alternative to the Rust version where everyone has to use it and you're forced to use it. Yeah.
So I was a little confused by that last statement because I thought you said that that code that I didn't see any annotations on would not compile in the parallel part of your system.
Yes, so that is a bit of a different case where if I'm compiling parallel code, then it could infer, or the default function for OCaml, the default mode for OCaml functions is non-portable, right? So if I just take some library off the shelf that's an OCaml, I take a function, it's assumed to be non-portable. And so then I just can't use it in a portable setting. And if I want it to be portable, then I need to go rewrite that code with OxCaml or make sure that that source is available. So it is a little bit of a pay as you go, especially for the locals and locality, but for parallelism, you can't, you know, it's assumed that things are unsafe and you have to use it that.
Some stuff like the local stack allocation. I guess the local allocation, stack allocation. Feels like you could imagine a situation where like I don't want to think at like individual variable level, like, okay, my stack allocated is. Hey, compiler, do your best to like local allocate, stack allocate as much as you can. Do you is like some kind of automation for easy, like I guess flipping on the optimization to the best of compiler's ability to is that something on the horizon or not?
I believe that broadly exists, right?
Yeah, sorry, these modes are inferred, so
Yeah.
you don't actually have to write stack. That's a request to make sure something's stacked.
Yeah, that would be like I'm writing this function and I really need to know that there's no allocations, then I can go in and annotate things. And so then if something changes in the future, my annotations catch that safety the same way that types would catch, you know, an unsafe program. But these things are inferred, yeah.
So coming back to the previous question, so like basically it's not the case that every OCaml program that checks in OxCaml because of parallels.
Yes, that is true. I can take a truly unsafe parallel piece of code in OCaml, try and compile it in OxCaml, but then I would just get a type error.
Okay, but
I think OCaml work program checks.
right, and then once
Yeah.
you have parallelism, that does not, so it's not technically not backwards.
Although it's not a language question, it's a library.
Yeah.
We
Yeah.
ban the bad libraries, then you're.
That makes sense now.
Yeah.
Yeah, now we
Basically,
got it.
unsafe, basically the libraries need to be exploited with safe.
Okay.
Yeah, so we like our version of the sudlib, there's like a bunch of things have like a dot safe, and then inside there you have the safe version. Like there's another.
Makes sense, yes. So besides safe parallelism and better performance, are there other advantages? The reason that I'm asking is sometimes I find when writing Rust, it forces me to think about things that have nothing to do with memory management. They're still helpful for program design.
Okay.
Where have you seen this with modes where you're like, the mode has helped me think more clearly about my problem?
So I think a great example is, so locals, we talked about it in terms of stack. But really it's about whether things can escape this filter. So like in OCaml, there's a function called with like string, it's a file name, it's the file. And that function that you're going to run the contents of the file. And it would be a mistake to hold on to that after that authority grabs. The file's going to get closed and become this. So local allows you to say, oh, actually, you only have access to that. It's going to prevent you.
Yeah, and that's actually also true with the capsule code, right? Because I could in theory take this reference and try and stash it somewhere else. But it turns out that you only have local access to it, so it can't escape that function region. And so that provides us the safety.
So basically anything with the width pattern. It's a lot nicer.
Yeah, it makes it a lot nicer. Yeah, cool. Any other questions? If not, do the activities, open a code space, make Anil pay money for it, and JStream, and come talk to me throughout the week. Thank you so much.
Yeah, what usually triggers that? Is it feedback from developers?
Oh, I was supposed to tell you, there's a concert tonight.
No, you can check it.
Go to it. People want you to go to the concert. Please go. The farm concert. Yes, I was supposed to tell you.
Very good. Even double the energy the second time around. That was better. Oh, this one, see from it.
Yeah, that's the whole thing. Although I think there was a thing where every time I walked out of it, they like activated the zoom on my laptop.
Oh, the one.
And it kept bugging me because I would see it and I was like, I can't walk this way. Yeah.
Yeah, you guys have to get that.